Hello everyone, myself Sumit Maheshwari, working as an assistant professor in ABES Engineering College, Ghaziabad. Today I'm delivering a lecture on numerical solving of parallel AC circuit. So this is our numerical. We have a series parallel combination in which there is a Z1 which is 8 plus J6 ohm and and here that is Z2 and Z3. We are finding the total impedance of the circuit, then branch current Z I1, I2 and I3 and total power loss in the circuit and power factor of the circuit. So we have Z1 8 plus J6. We are converting this in polar form, which is 10 angle 36.87 degree by using calculator. Similarly, we have Z2 which is 3 plus J4, that would be 5 angle 53.13 degree. Now we have Z3 which is 5 minus J12, and this is converting into the polar form which is 13 angle minus 67.38 degree. So when we are taking parallel combination of Z2 and Z3, we need to calculate Z2 plus Z3, which is the real part of Z2 and Z3 is 3 and 5. So which is 8, and the imaginary part minus k J12 plus J4, which is minus of J8. So after solving into the polar form, it is 11.314 at an angle minus 45 degree. We also need Z2, Z3. So we are multiplying Z2 and Z3 in polar form. 5 angle 53.13 degree, 13 angle minus of 67.38 degree. So after multiplying, it is 65, and in multiplication, angle will be added. So minus 67.38 degree minus plus 53.13 degree, which is minus of 14.25 degree. So this is Z2, Z3. So now we are calculating Z total. So what would be the Z total? Z1 plus parallel combination of Z2, Z3, which is Z2, Z3 upon Z2 plus Z3. So put all the values. 10 angle 36.87 degree plus 65 angle minus 14.25, which is Z2 Z3 multiplication upon Z2 plus Z3 11.314 at an angle minus of 45 degree. So this is Z1 plus Z2 Z3 upon Z2 plus Z3. So when we are calculating this is 10 angle 36.87 degree plus, after calculating this is 5.745 angle 30.75 degree. When we are adding these two polar quantities, we are getting 12.937 plus J times of 8.937 and convert into the polar form, which is 15.724 at an angle 34.64 degree. So this is our Z total. This is mod of ZT. This is RT, resistance of total equivalent circuit, and this is XT. So this is our part A, in which we are calculated the total circuit impedance. Now we are calculating the B part, current in each branch. So first of all, we are calculating the I1. I1 is V supply upon total Z impedance. V supply is 200 angle 0 degree upon Z total. Z total is 15.724 at an angle 34.64. So after calculating this by using calculator, we will get 12.72 at an angle minus के 34.64 degree. Now we calculate the value of I2 by using current division formula. I2 is equal to I1 into opposite impedance in which branch current is divided. So Z3 upon Z2 plus Z3. So I1 12.72 at an angle minus के 34.64 into Z3 13 at an angle minus k 67.38 upon Z2 plus Z3. Z2 plus Z3 is 11.314 at an angle minus of 45 degree. After calculating this, we are getting the I2 14.615 at an angle minus k 57.02 degree. Now for I3, which is I1 into Z2 upon Z2 plus Z3. So 12.72 at an angle minus k 34.64 degree into Z2 5 at an angle 53.13 degree upon Z2 plus Z3 11.314 at an angle minus k 45 degree. So after calculating this whole expression by using calculator, we are getting the value of I3, which is 5.62 at an angle 63.48 degree. We also calculate I3 by using the KCL. I1 is equal to I2 plus I3. And if we calculate already I2, then I3 is equal to I1 minus I2. So we will get the same result. So in such a way, we find the current in each branch. Now we are calculating the C part, total power loss in the circuit. So total power loss is IT square and RT. So we already calculate I total current without taking angle. We are putting here only mode. So I total 12.72 square into RT 12.937. So after multiplying this, this is 2093.18 watt. There is alternative method. If we are calculating the power loss in each branch, then we also calculated the total power loss. So the total power loss is equal to power loss in branch 1, power loss in branch 2, and power loss in branch 3. So power loss in branch 1, I1 square R1, I2 square R2, and I3 square R3. So the I1 square R1, 12.72 square into R1. This is R1, 8 plus I2 square R2, 14.615 into R2. This is our R2, 3 plus I3 square R3. So the value of I3 is 5.62 square into R3. This is our R3, 5. After solving this expression, we are getting the similar result, 2093.11, which is almost equal. Now we are calculating the D part, power factor of the circuit. So cos phi, we are calculating by RT by ZT, from which when we calculate the total impedance. So the RT is 12.937 divided by 15.724. After calculating this, this is 0.822 lagging. Another method to calculate the power factor is cos phi P upon VI. So the total power loss, 2093.18 divided by 200 into I total. So 12.72. After calculating, we are getting the same result, 0.822 lagging. So in such a way, we are calculating the impedance, current in each branch, and power loss in the circuit, and the power factor of the circuit. So these are the references. This question is taken from J.B. Gupta of Basic Electrical Engineering book. These are our disclaimer. Thank you. In next lecture, we are discussing some more numerical on this topic.